Hello and welcome students. In the last video lecture, I had started chapter number 2 of statistics, that is presentation of data. In that, I had explained you the two methods of classification of data, that is the discrete frequency distribution and continuous frequency distribution. What is the difference between the two frequency distribution? Inclusive frequency distribution, exclusive frequency distribution, and the formula to convert the inclusive data into exclusive data. These many topics that we had covered in the last video lecture. Now in this video lecture, I am going to explain you the formula to find the mid value. Okay, so you can see on the board that I have written that is mid value of class. If in a question it is asked to you to find the mid value of the classes given, then you have to apply the given formula, that is UL. I have written that is short form, upper limit plus lower limit divided by 2. It is same as the average. Suppose one class is given to you, say that is 10 to 20, right? So what is the upper limit? That is 20, and what is the lower limit? That is 10. So upper limit plus lower limit divided by 2. So 20 plus 10, that would come to 30. So 30 divided by 2. So the mid value, that would come to 15. Once you get the mid value of the first class, if all the classes are having equal class length, then once you get the mid value of the first class, then just you have to add the class length to each and every mid value, then you will get the subsequent mid values. This you will understand it by practical sum. At present, you just understand that whatever the mid value, suppose this is the first class, 10 to 20 is the first class, the second class is 20 to 30. Then 10, 20 to 30 means upper limit plus lower limit. So 30 plus 20, it would come to 50. So 50 divided by 2, it would come to 25. So for the first class, the mid value, that comes to 15. And for the second class, that comes to 25. Then what would be the mid value for the third class? That would be 35. Easily you can identify. You don't need to apply the formula each and every time, because the class length is equal for all the classes. So just you have to add plus 10 to each and every mid value. So easily you can get without the formula the mid value of all the classes. Okay, so this is the formula to find the mid value, that is upper limit plus lower limit divided by 2. Now if you want to find the upper limit and lower limit, if in the question mid value is given to you, but and lower limit is given to you, but upper limit is not given to you. So how to find upper limit? Upper limit is equal to mid value plus half of class length. Okay, these formulas you both have to remember, that is upper limit is equal to mid value plus half of class length, and lower limit is equal to mid value minus half of class length. Both the formula is the same only, but in case of upper limit we have to do plus half of class length, and in case of lower limit we have to do minus half of class length. Okay, so these formulas you have to remember while finding the mid value if you want to find upper limit or lower limit. Okay, now last video lecture we had done 2 illustrations. Now today I am going to explain you illustration number 3 and illustration number 4 of your textbook. While I am reading the question, you also refer from the textbook while referring with the video lecture. Illustration number 3, that is on page number 21 of your textbook. During a season of 50 days, the data regarding the number of roses grown daily on the different plants in a garden are given below. Yani ki during the season of roses, there are 50 days that are taken for survey, and number of roses that are grown daily on the different plants in a garden that are being counted. Prepare a frequency distribution from it having one class as 30 to 39. It has been clearly specified to you that one class that should be 30 to 39. Okay, now we have to find out first of all the range, whether it is sum by discrete frequency distribution or by continuous frequency distribution. The first point is to find the range. Okay, so you can see I found the range over here. Already we discussed in the last video lecture what is the formula, that is maximum value minus minimum value. From the 50 data that has been given to you, you can see that the highest value or the maximum value, that is 99, and the lowest or minimum value, that is 70. So 99 minus 17, so the range that would come to 82. And already it is given in the question that one of the class that should be 30 to 39. It means here we have to apply continuous frequency distribution, and also the range is comparatively large. If the range is large and already it has been told to distribute the data in the classes, so here we have to apply continuous frequency distribution. Okay. So, and telemarks already we discussed, that is very easy. But first of all, we have to decide the classes. Now, one class that has been given to you in the question, that is 30 to 39. Now, 30 to 39, then to maintain equal class length, we have to start with the first class that is having the value that is 17. We have to start the classes covering the minimum value that is 17. So the first class we have taken, that is 10 to 19, in which the minimum value 17 should come. Okay, so our first class should always be having the minimum value in it. Over here 10 to 19, so 17 will come in 10 to 19. So always the first class should cover the minimum value, and the last class should cover the maximum value. See, 90 to 99, what is our maximum value? That is 99. So in the last class 99 would be coming. Yes, okay. So 90 to 99, that would be our last class. Okay. So we have to carry our classes up till it covers the maximum value. Okay. Now after deciding the classes 10 to 19, 20 to 29, 30 to 39, 40 to 49, and so on. So total how many classes have become? That is 3 plus 3, 6, and 3, 9. So total 9 classes that we have distributed the entire data. Now you can see from the data that 10 to 19, 20 to 19. So which type of data it is? It is inclusive frequency distribution. Again, I am revising the topic because it is important. Inclusive and exclusive. Inclusive distribution, it means the upper limit of the first class and lower limit of the subsequent class. Upper limit of the first class and lower limit of its succeeding class are not equal, then it is called inclusive frequency distribution. But suppose the upper limit of the first class and lower limit of its subsequent class are equal, then it is called exclusive frequency distribution. Okay. Okay, now after deciding the classes, we have to put the telemarks. That is quite easy. You have to just see the values each and every one, that is 34, 26, 49, so 45. So accordingly 34, so it comes into 30 to 39, just you have to put telemarks. This is in lower standards you have done, so I am not doing this calculation. Easily I have put, there's just the telemarks over here. After getting the telemarks, you have to found the frequency. Over here you can see it is 5, so 5. Over here also 5, 5 plus 5, so 10. Over here 3, 5 plus 3, so 8, 5. And afterwards 5 plus 2, so 7. Over here 4, and last that is 3. Already I discussed in the last video lecture also that the total of this frequency that should be coming equal to the number of data that has been given to you in the question. Over here you can see the frequency is coming to 50, and the number of data that has been given to you is also 50. So always it should get tailed. If over here it is coming 48 or 49, it means somewhere you have missed out any of the frequency. So your answer is not correct. So always the total of frequency and the number of data that has been given to you in the question should be tailed, should be equal. Okay. So this was the basic illustration. Now next illustration, that is illustration number 4 that I am going to explain to you. That is on page number 22 of your textbook. Let us read the question first of all. By considering the inclusive frequency distribution obtained in illustration 3, it means this we had already discussed, that this is inclusive frequency distribution. From this inclusive frequency distribution, based on this illustration 3, we have to calculate illustration number 4. So this is our question for illustration number 4. Okay. Based by considering the inclusive frequency distribution obtained in illustration 3, find exclusive frequency distribution and frequency distribution showing mid value of each class. It means two topics here we have to find out. That is, whatever the inclusive data that has been given to you in the illustration number 3, from that inclusive frequency distribution we have to convert it into exclusive frequency distribution. And the second table that we have to find the mid value of each and every class. Frequency, there would be no any change, just we have to convert the inclusive classes into exclusive classes. Okay. So over here you can see the first inclusive class, that is 10 to 19. Now I have taught you two methods in order to convert inclusive class to exclusive class. First formula, by the help of formula also you can calculate the lower limit and the upper limit of the exclusive frequency distribution. But over here the alternate method also I have taught you in the last video lecture. Again I am revising that alternate method. Whenever you want to convert inclusive frequency distribution into exclusive frequency distribution, subtract or minus 0.5 from the lower limit and add 0.5 to the upper limit. Okay, so over here you can see what is our first class, that is 10 to 19. What is the first class? That is 10 to 19. Okay, we have to convert it to exclusive frequency distribution. So what I have told, subtract 0.5 from the lower limit. What is the lower limit? That is 10. Subtract 0.5 from 10. So it would come to 9.5. Okay, and add 0.5 to the upper limit. What is the upper limit? That is 19. So 0.5 add to it. So it would come to 19.5. Okay, so this is very easy method instead of applying formula for each and every classes. Okay. Now, so first class that would come to 9.5 to 19.5. We have subtracted from each and every lower limit, we have to subtract 0.5, and from each and every upper limit, we have to add 0.5. Okay, so easily you will get the inclusive data to exclusive data. Okay, so over here we have found the exclusive classes by just subtracting and adding 0.5 to the lower and upper limit. Okay, so as you got the first class, second class, that is 20 to 29. So second class, that is 20 to 29. So subtract 0.5 from 20, that would come to 19.5, and add 0.5 to 29, so it would come to 29.5, and so on. You will find all the exclusive classes. Now after finding the exclusive classes, the frequency would remain as it is, as you have done in the previous illustration, that is same 5, 5, 10, 3, 8, 5, 7, 4 and 3. Same frequency will be over here also in case of exclusive classes. Total that comes to 50. Okay. Now the next question, sub-question that is in this illustration, that is you have to find the mid value of each and every class. Now just normally we had studied what is the formula to find mid value, that is upper limit plus lower limit divided by 2. Okay, so basically our classes that are inclusive classes 10 to 19, 20 to 29. So as it is, I have written the classes. Okay, now we have to find the mid value. How to find the mid value? That is upper limit plus lower limit. What is the upper limit over here? See, first calculation that I have shown to you. Upper limit, that is 19. 19 plus 10 divided by 2. You can write 10 plus 19 also, 19 plus 10. Doesn't make any difference. Okay. So 10 plus 19 divided by 2. 10 plus 19, that would come to 29. 29 divided by 2, it would come to 14.5. Okay, now each and every time I have not applied the formula, because you can see the class length is equal amongst all the classes. So just I will add the class length to the first mid value. Over here 14.5 came the first mid value. So plus 10 I will do, then I will get 24.5. 24.5 plus 10, then it would come 34.5. 34.5 plus 10, then it would come 44.5. In short, whenever the class length is equal in between of the all the classes, then each and every time you don't need to apply the formula of mid value. Just you add the class length to each and every mid value to get the subsequent or the consecutive mid values. Over here you can see first mid value calculation I have shown. Then afterwards I have not shown the calculation for all the mid values. Just I have done plus 10 to each and every mid values. Okay, so that is the way to find the mid values. Next, that is frequency, that is the same as what is given in the question, same I have just copied it over here. Okay, so these were the two important points of illustration 4, that is how to convert inclusive data to exclusive frequency distribution and how to find the mid value of the classes that has been given to you. Okay, so these are the 2 points today that we have studied. Now I'll take one of the question from the exercise also. So open the page number 20, sorry, let me check it out. Page number, that is 36 of your textbook, that is exercise 2.1. Exercise 2.1, question number 1 today we are going to do. Let us read the question first of all. It is on page number 36 of your textbook. Question number 1. The data regarding the number of children of 50 families residing in a certain area are given below. Number of children of 50 families, the data has been given to you in the question. Prepare appropriate frequency distribution. Now we have to decide. Appropriate means we have to decide whether we have to do the calculation by continuous frequency distribution or by discrete frequency distribution. First of all, the first step that we have to find the range. Over here you can see I have found the range. Range is equal to highest value minus lowest value. It means maximum value minus minimum value. Okay. So highest value, you can see from the data, the highest value, that is 3. There is no any data more than 3. So maximum value, that is 3, and lowest value, that is 0. So 3 minus 0 is equal to 3. So the range is comparatively smaller. If the range is smaller, it is always insisted to do the calculation by discrete frequency distribution. Okay. So over here I have started discrete frequency distribution with the lowest value, that is 0, and ending up to the highest value, that is 3. So 0, 1, 2 and 3. Now telemarks that we have to do from the data that has been given to you. So let us place all the values in the telemarks. First one, that is 1, 0, 2, 3 and 0. 1, so it would come over here, 0, 2, 3 and 0. Okay. Then afterwards 1, 2, 1, 0, 1. 1, 2, 1, 0 and 1. Okay. Then afterwards 2, 2, 3, 3, 2. 2, 2, 2, 2, 3, 3, 2. Okay. Then afterwards 1, 0, 1, 0, 2. 1, 0. So 1, 0, 1, 0 and 2. Okay. 1, 0, 1, 0, 2. Then afterwards 1, 3, 1, 2, 2. 1, 3, 1, 2, 2. 1, 3, 1, 2, 2. Okay. 1, 3, 1, 2, 2. Then afterwards 1, 3, 2, 1, 2. 1, 3, 2, 1, 3, 2, 1, 3, 2, 1, 2. Okay. 1, 3, 2, 1, 2. Okay. Then afterwards 1, 2, 2, 3. 1. So we are writing 1, 2, 2. And last, that is 3. Okay. Then afterwards 2, 1. 3 times 2. 2, 2, 2, 1, 2, 2, 3. 2, 1, 2, 2 and over here that is 3. Okay. Then afterwards 1, 2, 1, 2, 2. 1, 2, 1. So 1, 2, 1. 1, 2, 1, 2, 2. Okay. Then afterwards 2, 2. Okay. Last one, that is 0, 1, 2, 2, 1. 0, 1, 2, 2, 1. Okay. Okay, last one that has been completed. Now we have to count the telemarks to get the frequency. The first one that would come 5 plus 1, so it would come to 6. Second one, that is 5 plus 5, 10, 10 plus 5, 15. 15 plus 1, that would come to 16. Then afterwards you can see 5, 10, 15, 20 and 21. Okay, and last one, that is 5 plus 2. So it would come to 7. Okay, so let's count it. 21 plus 7, that is 28. 28 plus 6, it would come to 34, and 34 plus 16, that would come to total, that is 50. Okay, so always I had told that the total of frequency that you are getting, that should be equal to the number of data that has been given to you in the question. So you can see in question number 1, the data total, that is 50 data that has been given to you, and over here the frequency also came to 50. So our answer is correct. So that's all for today, students. Still we have to go a long way in this chapter. Do revise again from the video lecture. See you in the next video lecture. Till then, goodbye. Keep practicing. Stay blessed.